So that got disconnected unexpectedly. So I just have to reconnect again. Sometimes technical issues happen beyond your expectation. So we're actually calculating the probability of a meal that a meal closes one or fewer deals in a week. So that should be probability of closing 3 deals, 0 deals, probability of closing 0 deals, plus probability of closing. So let's submit the line of code and see. Ooh, we didn't get that. Okay, let's see. That's one way to do it. All this was wrong. So if we just use 1, 3, and 30%, so we could use binom.cdf rather than using binom.pmf to do that over. So CDF will do that. That's another 7 of your deals. So for this, we're going to use the binom.cdf function. So you can just watch the video where this different CDF binom.rvf, CDS, or PMF was being explained. So you can know the difference between the different function. So that is 34%. Let's submit that. Oh, we didn't get that also. What is wrong? So one or fewer deals. So it's going to be one, or I could just use one. So it'll be one or fewer deals. Probability of army closes one or less than one. So that is 0.78%. Okay, that was my mistake there. Interesting. Probability of closing one deal out of 3 deals. That is 1, 3. So that is the result there. That is 0.78%. Okay, that's 78% rather. So what is the probability that army closes more than one deal? So more than one deal, that should be CDF. So I'm going to be using CDF in this instance here. The army closes more than one deal. I'll be binding the CDF. That's CDF. Open brackets. So then this is what we get. One minus one deal greater than one deal. Then 3 out of 3 deals, the probability of success is 0.3. Let's run the code. That would 21% success rate of closing more than one deal. Interesting. So we knew those concepts, the probability calculation there. That's 21% also. So powerful probability calculation. Amira has about a 22% chance of closing more than one deal in a week. Interesting. Oh, so we've been learning about the past 49 days. So how many sales will be won? Now Amir wants to know how many deals he can expect to close each week if his win rate changes. Luckily, you can use your binomial distribution knowledge to help him calculate the expected value in different situations. Recall from the video that the expected value of a binomial distribution can be calculated by n times p. Yes, so expected number of heads out of 10 flips. So out of number of flips, maybe number of win or loss, the probability, that is the answer here. So calculate the expected number of sales out of the 3 he works on that Amir will win each week if he maintains his 30% win rate. So we also need to calculate the expected number of sales out of the three he works on that you win if your win rate drops to 25%. Then calculate the expected number of sales out of the three he works on that he will win if his win rate raises to 35%. So I'm going to be calculating three different probabilities here. Okay, let's do that. So I'm going to be calculating three different scenarios there. If his win rate should drop from 30 to 35 or 25%, then 35%. Okay. 130%. So the first thing is to calculate the expected number of sales out of the three he works on that Amir will win each week if he maintains his 30% win rate. So for 30% win rates, that will be 3 wins out of 30% chances or probability. Okay, expected number of win with 25% win rate. That will be 3 times 0.25 percentage, and expected number of win 35% win rate. That will be 3 multiplied by 0.35 win rates. So let's print all that. So that will be 0.8, 0.75%, and 100%. Wow. So if his win rate should get to 35%, he has a 100% chances of winning all the deals. Interesting. Okay, we ran the code before. It's almost the same thing. Excellent manipulation there. Okay. Let's do the same thing here. So we have almost same result as earlier. So if his win rate should maintain, if he should maintain the 30% win rate, is expected to win 89% of the deals. If his deal should if his win rate should drop to 25%, so he's expected to win 75% of the deals. But if his win rate should increase to 35%, he's expected to win 100% of the deals. Oh. So excellent expectation experiment. So if Amir win rate goes up by 5%, he can expect to close more than one deal on average each week. Hmm. More than one. So more than one is not specified. So it's probably going to win one, two, or even win all. Okay. Probability is kind of tricky, man. So we've completed this last part of the probability lesson. So we're now moving to the normal distribution. So more distribution and central limit theorem. This is quite a lot. Oh. So let's see. So let's go ahead. So probability is inevitable as a data analyst. You have to know your probability very well. So that will be the end of the live stream for today. All right, so that will be the end of our live stream for today. So as we continue to other distribution, so we learned all about continuous distribution, discrete distribution, and binomial distribution. Those are some technical stuff. So you have to get yourself with as a statistician or a data analyst. So I'll see you tomorrow as we continue to other distribution that we have. I think we're moving to normal distribution, another concept in statistics that has to do with central limit or theorem. So we'll see what we learn to cover in those next lesson. I'll see you in the next video on the channel, or just make sure to download these files, the exercise files and Python files, so you can also practice your probability and statistics skills also. As usual, do have a wonderful rest of the day. I'm getting back to work.